everyone, welcome back to my channel, and today we're going together solve the daily LeetCode problem. So for our today problem, that is still like the problem with 40%, and however I don't think that is too difficult for you guys to solve this problem. However, I will share my approach. Yeah, so in here again we have the hash map problem, but this one is not about the frequency one. Yeah, so intuitively when we look into the problem, and then we need to count how many points which satisfy the conditions, like it have 1 point on the left, 1 point on the left, 1 point on the right, 1 point up, and 1 point down, and it means that like 1 point in the middle, and it is covered by other 4 points in that 4 directions, and then it is satisfied the condition. Yeah, so here like we can have the green point like this, and then so it has the 1 point on the left, 1 point on the right, 1 point up, and 1 point down. Yeah, so however, like in here, what if I take another point? For example, if I take another point in here, let's take another point in here, and then so let's change the color. Okay, for this case, so I want to demonstrate that like, okay, so here if we take a look into the points, and then so we can see that like the condition is just that like there is 1 point on the left, right? Okay, so it means that if I consider this point, and which point on the left should I choose, right? And what if I choose this point, and what if I have 1 point here? Okay, so the answer is that like all of them share the same point on the left, which is the point with minimum value in terms of the x, right? And they also share the same points on the right, which is the largest point in the x as well in here. So for example, like in here, what if we fix the y-axis, and then it means that like we only need to care about the for this point on the left in terms of x-axis, and for this point on the right on the x-axis as well. So let's say that this one is the max, and this one is the mean point in the x-axis. And also if we take a look, and then what if we want to consider this point, and then what if we want to check in terms of the y-axis, it means that we are fixing the x-axis in here, which is like the yeah, so in here what if we try to find the x-axis, it means that the same principle, the same rules will be applied. So we only cared about the max point and the mean point of this one. It means that like if we just consider about the mean point and the max point, right? It means that like for all set of the points in here, we only cared about the mean and the max. They share the same mean and max value, and it can be guaranteed that at least the points are covered in terms of one directions by its max and it means, right? Yeah, so that is the idea. So for example in here, when we check this point, and then we still say that okay, this is the point which is the mean, and this is the point up, and this is the point down. The reason why in here is that like this is the directions of the y-axis, it is reverse compared to the normal coordinate. So that is the reason why here is the number 5, this is the 1. Okay, yeah, so it means that the idea in here is like that is very simple, that like we just need to care about the for example, like if we fix the y in here, and then we just care about the mean and max in terms of the x-axis, x mean and x max, and yeah, so that is the thing. So it means that like, so for example, like we can just need to check how many y-axis we have. So it means that we just imagine that like when we have one x as a y-axis like this, and then we draw the row, and in here all of them will share the same key, which is the 3, right? And their max and mean will be that is the set bit. We will find the max between 1, 2, 3, 4, and 5. So apparently, so somehow in here, like we can conclude that like for the 3 we have the mean is 1 and max is 5, and then any point lies between this range, and then it is covered by the left and right. Okay, so that is the idea. So for now we will jump I will explain how can we implement it intuitively. So for example, like in here, for example, like we I will start with the y first. Okay, so for example, like in here we have y, this is the x, right, and this is the y. And then so in here, so for example, like we will have the hash map. Let's say the hash h of y, we will initialize that is empty, and then so we will iterate through the points. For the first point in here, we can see that this is the pair of x and y, right? Okay, so for now we will initiate it as the y, because there is nothing inside the hash map, right? So it means that like in here I will get the y, which is equal to the x and x. It means that this one is the mean, x mean and x max. Mean and x max, right? Okay, so in here, so yeah, so it means that we have what? In here we can see that y is 3, and then so in this hash map we have the mean and max, that is the 1 and 1. Okay, so 1 and 1. So do we have x is 1, and x is 1, and then x mean is 1 and x max is 1. Okay, that is 3. So that is, which point is that? Okay, so here, so we have to initialize the hash map. And okay, so next when we iterate this one, and then okay, we will see the another one, which is the y equal to 2. So it means that we have the 3 and 2 here. So this one is the 1 and 1. And what is the 2? The 2 is the 3 and 3, right? Based on our logic. Okay, so we will move into the next element. Next element here, so we can see that that is the 3. Okay, so we will compare that. If this value are smaller than this one, or this value greater than this one. If that is smaller than the x mean, and then we will update the mean, and if it is more greater than the this one, and then we will update the max, right? So it means that like in here it will be updated at the mean is the 1, right? And the max is what? Max is 3. Okay, so the 2, that is the 3 and 3. Okay, so for now we next. So this one we have the y equal to 5, and then so here that is the 1 3. For the 2 we have the 3 3, and this one we also have the 5 and 3 3 as well. And then lastly we can update this one, and this one it will convert this one 3 into the, that is the 3, and then that is the 1 and 5, right? And that is the 2 3 3, and that is the 5 5 3 3. Okay, so in here we can see that somehow like the 0.33 yeah, okay, so here like we need to do another one for the x-axis as well. We do the similar thing. So yeah, so for the x-axis, indeed we can choose the same thing in the same loop iteration. So here, so for example, this one is for the x, this one is for the y, and then we can do similar thing for the x. For example, like this one, x would be 1, and then it will be initialized with y mean and y max, right? Y max, right? That is the 3 and 3. Okay, so for the 3 it will be initialized as the 2 and 2, right? Okay, next element, this one. Yeah, so this is the second one, and then so we will have the 3 as the Okay, so we update the 3 again, right? 3 again, and then it is greater than 2, and then it can be transformed into 1 1 3 3 and 3 2 3, right? Okay, so next we will this one, and then that is 3 again, and then so here like we get the 5. So it means that like 1 we still keep it as the 3 and 3. 3 we that would be the 2 and 5, right? Okay, so next the 5, that would be the 3 and 3. Okay, so so for now we need to iterate this one again for each point. For example, like if we are given xy that is equal to the 1 and 3. Okay, so for now let's say that I have 1 here, right? I have 1 here at the x, as the x, this one is the x, and then I will refer to what? I will refer to the x here, that is the 3 3, right? So it means that like we have that one is this point, and then we can see that like, okay, so we don't have the point on the left smaller than y, and then the right greater than y, right? The y is 3 here. We compare this y with the y min and y max, and we can see that this condition is not satisfied, right? So we do not count it. Yeah, next point. So let's say that for now, what if we need to check this point, the 3 2, x is 3, and then y is 2, x is 3. Okay, x is 3 here, and then 2 5, and then so x is 3 1 2 3, and then that is the 2 2 here, right? However, this so for now we can see that this condition is still not satisfied, because like 2 in here equal to 2, right? We do not expect equal in here, we expect the greater, because the 2 points will be not overlap. Yeah, so that is a thing. Then this point is not satisfied as well, so we will go jump into the next point. Okay, so what is the next point? So next point is here. We will check this point 3 3. Okay, 3 and 3. So for the x, it is in this range, right? Range of 3. Okay, so for the y, we jump into the y here. So and then we check this one, and then apparently 1 smaller than 3 and the smaller than 5, and then it means that like we increment count by 1, right? That is the 1. Okay, so next we check this point. Okay, that is 3 and 5, right? That is 3 and 5. 3 and 5. Okay, so we can see that in this case x is 3, right? We refer to this, and then we check the y. This condition is not satisfied, so it means that this cannot be counted by 1. And also we check this one, and the 5 3, it also does not satisfy the condition, so that is the reason why we keep the count equal to 1. Okay, so for now, like we will program it together. So initially we need to forget the x-axis equal to 0, and sorry, we will initialize, that is the hash map, right? And the y-axis, that is empty hash map as well. And then for now, like we can iterate through the x and y in the buildings, right? And then from here, if the x not in x-axis, and then what should we do? We will initialize the x-axis of x that is equal to the y and y, right? That is the initialized value. And now what else? If it is inside the hash map we predefined, and then somehow like we get the x axis of x would be sorry, for now we will check. Let's say that the first element is the mean and the second element is the max, and then we will check the x-axis. If the x-axis of x of 0, right, smaller than y, and then we update the y. X of 0 and then will be equal to y. We update the mean, right? And then if the x-axis of x and 1 greater than y, and then we will update the x-axis of x and 1 equal to y. We update the upper bound. Okay, so we can do the same thing for the y-axis as well. So we can do exactly the same thing. Yeah, we can do exactly the same thing. However, in here, like, we need to transform it into the y, and this one is the y-axis, and for the y-axis we will take in the x mean and x max, and for each iterations, and then we will update the x mean and x max, right? Here is the y, and this one is the y, this one is the x, and this one is the x, and we will transform it into y and y. Okay, so this is how we can create the hash map, and in this hash map, and then we only store the min and max, and after this, and then we can safely initialize the count equal to 0. And for now, we iterate through the buildings, and then with this building we will get the status, for example, and then let's say that I need the false, because we have two conditions. And yeah, so for the first condition is that, like, if the x-axis of x and 0 is not equal to the x-axis of x1. Yeah, I just want to avoid the case like y in here or x in here, right? I don't want to do that. So yeah, and then if condition is like satisfied, and then we will get the if the x if the y greater than this one, we can get the conditions, and y smaller, it means that it is in the range, right? And then we will set the x dot equal to 2. Okay, so we can do pretty similar things for the y. We can get the y status, and then we get the y, and then we have put here is y, and this is for the x, and this is for the y-axis, for the x, for the y, and this is the y status. Okay, so and then finally, if the x stat and y stat, we will increment count by 1, and we can simply return count. Yeah. All right. Okay, so in sorry, so in here, like, yeah, if x-axis of 0 greater than y, and then we update the upper bound, and if that is smaller, that is reverse way. Yeah, so in here it means that, yeah, I did the wrong thing when I yeah, so for now you can see that in here we pass on the test case. So the step update, my step updates here, it is like, yeah, sometimes I didn't recognize that this one should be reverse way. Yeah, so it means that, like, if the existing one is greater than the current one, so it means that we update the lower bound, otherwise we update the upper bound. Okay, yeah, so let's submit. Yeah, so I think that this is the simple and easy approach for us to solve this problem. Yeah, so you can see that, like, if we just program it safely, and then so we can get accepted at the first time, Yeah, so thank you so much for watching my video, and if you like and if you want me to share more videos in the future, please give me a like or comment. Again, thank you so much for watching my video, and see you next time.